Now let's talk about some transformations of exponential functions. So we know our basics, and now we need to know our transformations. And so the horizontal transformations or translations, remember that goes left or right. Left or right. And then remember in the inside, so if we're looking at what we're going to use is y equals b to the x minus h plus k. So with the horizontal translation, it's going to be with x in the exponent. Okay, in the exponent. So see it here, we have x minus h. That's how you know it's going to be a horizontal translation. Now remember, with the left, you'll actually see a positive number, and then for the right, you're going to see a negative number. So 3 units to the right, we're going to use 4 to the x, 4 to the x. So that's going to be 4 to the x, and then to the right means a minus 3, and it's all in the exponent. Then if we go to the right, still using that same function, g of x equals 4 to the x, to the left will be a plus 2. Vertical translation, that is up or down. And then so we're going to look at our plus k at the end or minus k at the end. Okay, so it's on the outside, plus k, or just k on the outside. So 5 units up would be g of x equals 4 to the x, and then it just keeps the same sign. Plus 5 means up 5. And then for 1 unit down, that'll be g of x equals 4 to the x and minus 1. Now, knowing those transformations, what we're going to do next is look at some graphs. And given the graph, we're going to identify whether it's a growth decay. We'll identify the parent function, what type of transformation, and then write the transformation, the function of that transformed graph. So we're looking at this graph, letter C, and so it's going up from left to right. So it's growing. So know that it's growing. So therefore, this is a growth. Because it's going up from left to right, it is a growth. So the parent function, what we want to take a look at, number one, 0, 1 is always there. So that's kind of a good home point, is what I would say. And then we can take a look at the next point, 1 comma b. So if we're looking at this value here, we can count, and this point, so find out what this point is, it's at 1, 2, 3, so that is at 3. So if it's at 1 comma 3, then we are at 3 to the x, okay, 3 to the x. So we're just trying to find that b value, b, and then what is that x, the exponent here, b to the x. So this is 3, this point is 1 comma 3, so it's 3 to the x. Now let's look at the transformation. So we're here, and so we're trying to find that same point on the g of x. So notice it's going to be the middle point. And so we're going to count 1, 2. So we see that it's 2 left, 2 to the left. So if we're given the parent function 3 to the x, to the left, that's with the x. And then that's going to be a positive 2 in that exponent position. So let's try, I'm going to skip down to E. We're looking at this example. We want to decide if it's a growth or decay. So it's going down from left to right. So it's decreasing. So we can say it's a decay. So if it's going down from left to right, then it is a decay. Now the 0, 1 is our kind of like our home point, so that's important. It's hard to tell what the value is though by looking at this next value, the 1 comma b. So it's hard to find. So what we're going to find instead is -1 comma, and we'll see what this value is. And so this top number, let's see, -1 up 1, 2, 3, 4, 5. So it's -1 comma 5. So we could either look at it as it's 5 to the -1, right? Because the x value are our exponents. And so it's 5 to the -1, then it's 1 over 5 to the x power. 1 over 5 to the x power. Okay, so what you're going to do is use this. If you see a -1 in that number, then you know right away it's going to be a fraction. So you can just write it 1 over 5 to the x, right? And then this here is probably 1 comma 1/5. The transformations, if we're looking here, looking at this point, and it's the middle one of the three, so it's going to move 1, 2 up. We also notice that our asymptote moved, right? So it's approaching this value here, it's 2. So notice that also moves as well with it. So it moves up 2. So then we can write our function as 1/5 to the x and then plus 2. And of course using our g of x. So try these two out, letter D and letter F. So see if you can figure out what the parent function is first for both, what is the transformation, and then write the function. So pause the video and try this out. So trying this out, the first one is 2 to the x. So you can find that by looking at this first point. So we always have 0, 1. And then the next one is 1 comma b. So it's at 1 up 2, so 1, 2. So that is our b value, 2 to the x. Then we notice how is it shifted. It moves down 1, 2, 3, 4. So it's down 4. You kind of take a look at the asymptotes as well. That kind of helps you. The asymptote also moved down 4. So notice it shifts with our graph. And so if you write it, it's 2 to the x minus 4 on the outside. For letter F, so those are a little harder to read always because it's hard to read the fraction. So instead we look at the left side. So if it's a decay, you're going to look at the left side. And we see that it's this point here is -1, 3. So then if you see a -1, 3, it's a fraction of 1/3 to the x power, right? And it's a decay, so it should make sense. So if you say it's a decay, oh, I didn't mark that. If you say it's a decay, then it should be less than 1, and growths are always greater than 1. So to find that point, this is -1, 3, it's 1/3 to the x. Then you look at how it's shifted. So you find that middle point also on that blue curve. And so it just shifted 1, 2 to the right. So therefore we write 1/3 x and a -2 with the exponent. Now just to kind of take a look at multiple transformations. So it'll go up, down, left, right. So what we're going to do combination transformations. So letter D is similar to what we did before. We want to find the parent function first. And so we'll take a look at, this is our origin, right? The origin is here. And so f of x is always our parent. Okay, so it's in purple for all of these graphs here. So f of x. And so this is our home point here, 0, 1. And so it's growing, right? It's going up from left to right. So it's a growth. So the number should be greater than 1. And so we see that it's 1, 2, 3, 1 comma 3 is this point. So therefore the parent function is 3 to the x. Now let's find how it's transformed. So we're trying to find the middle point in the g of x, and that is here. And so let's see how it's transformed from the purple. So it goes left 1, 2, 3, 4. So it moves left 4. And then it moves from left 4, it goes down 1, 2, down 2. So now identifying that, we can now write our transform function g of x. So it's 3 to the x. Left 4 is actually a plus 4 with the x. Down 2 is -2. So then you'll try these for the rest of these problems just to practice writing functions. So identifying the parent function first, describe the transformations, and then write the transformed function.